Hi guys, welcome back to Paraclete TV. Today we will be learning how to solve problems using expressions, equations, and inequalities. Alright, let's get into it. Alright, so what is an inequality? It's when one value does not equal the other. It's kind of intuitive. So you know your basic equal sign, right? 3 equals 3, 9 equals 9, 9x equals 18x over 2. Equal sign indicates that the expression on both sides of the equal sign are the same. So when we're dealing with inequalities, we have expressions we can use to indicate that one side is either greater than, less than, or equal to the other side. So we have these arrowheads that indicate greater than or equal to. The way I was taught is that the mouth of the gator, I've drawn teeth here, always eats the bigger number because they're more hungry for the bigger value. So this open part of the arrow here is always facing the greater number. But obviously it can point to the left or the right, so we need to know how to read both sides. So when this or this occurs, this arrow or this arrow with the little line under it, it means the left is greater than or equal to the right. So over here, there's a bigger value or bigger expression than over here. And this little line under the arrow indicates that it could be equal to. And so for down here on the opposite side, the left is smaller than the right. So the left is less than or equal to the right. Now when we have inequalities and we have variables and we're trying to solve for x or y or this or that, solving the equations, we treat the expressions the exact same as we would an equal sign. We just keep carrying it down. We don't even really acknowledge it. We do what we do to one side, we do to the other, this and that. We treat the expressions as equal signs except when multiplying or dividing by a negative number. So I'll get into that. Okay, so when we're multiplying or dividing by a negative number, we have to flip the expression or flip the arrow to keep the right values on the right side. So here's an example. I have negative 9x is greater than or equal to 36. We're going to solve for x, and by doing that, we divide both sides by negative 9, right? So if we divide by negative 9, divide by negative 9, if we just keep this like this and treat it as an equal sign and carry it down, negative 9 divided by negative 9, x is that, 36 divided by negative 9 is negative 4. So that would be what we would think is our answer. But since we divided by a negative number, we have to flip the arrow so it becomes this instead. We'll carry all that down. X is less than or equal to negative 4. And that's really the only problem with inequalities, is that when we have negative numbers, when we multiply or divide by negative values, we have to flip the arrows. Okay, so I have two expressions here that we can solve very easily and plot on a number line. So the first one we'll do here. 5x plus 2 is greater than 62. We solve and we treat this greater than value expression as an equal sign. So let's just solve for x. What we do first is we minus 2 from both sides. So 5x is greater than 60, and we'll divide by 5, divide by 5, x is greater than 12. Now how do we draw this on a number line? Well, we know that an important value will be 12, we'll put that in the middle, and we'll do 13, 14, 11, and 10, and so our critical value here is 12. We'll put a circle around that. But here, x does not include 12. It is only greater than 12. So we will shade I'll use a different color. We will shade only greater than 12. So we have to leave this circle open because 12 is not included in the value. All right, so simple enough, right? So let's go to the next problem. 39 is less than or equal to negative 6 plus 3. We're going to treat the less than and equal sign as an equal sign. So we'll subtract 3 from both sides. 36 is less than or equal to negative 6 x. And we want to get x by itself, so we divide by negative 6, divide by negative 6. Remember, when we divide by a negative number, we have to flip the sign. So 36 divided by negative 6 is negative 6. We're going to flip that sign, so now it looks like this is greater than 6. So negative 6 is greater than or equal to 6. So now we're going to plot this. Again, our critical value is negative 6. And we'll do negative 7, negative 8, negative 5, negative 4. So our value here is negative 6. And x is less than or equal to negative 6, or negative 6 is greater than or equal to negative 6. So values that are less than negative 6 are negative 8, negative 7. So our number line is going to go here, right? We're going to shade this part of the number line. So any value that is less than negative 6 can be equal to x. But in this statement, we also have the inclusive x can be equal to negative 6. So we have to shade the circle as well, indicating that we're including negative 6. So when we have the value less than or equal to or greater than or equal to, we have to shade the circle. When it's just the arrow, we leave the circle open. Thank you guys so much for watching this video. Hope it helped. Bye!